Welcome everybody to the video of design of a mat footing using safe software. This mat footing will be subjected to loads from the building model as we have previously analyzed and designed using ETAP software in my previous video. As for the same, while going through the analysis result of the building, we found that the results are at par with the problem statement as given in my project problem statement. So I am using the problem statement from my project as follows. This is the first slide of the problem statement in which the building grids are shown. The column marks C1 to C16, total number of columns will be 16 numbers. Each grid of the building along X and Y axis will be 6 meter deep. That is also shown. And the safe bearing capacity SBC that we have to consider for the soil, that is 300 kilonewton per meter square, that is being given. As well, the allowable settlement that we have to restrict our foundation within that limit, it is 1 centimeter, that is also given. So from these two we can easily calculate the modulus of subgrade reaction on the foundation system while going through the modeling analysis and design of the foundation. Let us now move on to the second slide. This is the second slide of the problem statement in which the column against each of the column markings, the dimensions, dead load, live load, and the material for each column is been written. This is from column marking C1 to C8, and in the next slide, which we will be going now, this is the third but last slide in which all the column names against each of the column names, the column sizes, dead load, live load, and material specification is given for third columns from C9 to C16. So that is the problem we have to solve. Let us move forward. Now we are into the SAFE 2016 software. We will be starting our model as per the problem statement. First, let us open a new model. Let us click on that. Select the design code as IS 456-2000. Let us check the unit, that will be metric. And the design preference, let us check the minimum cover of slabs, that we have to provide 50 for the footing, and preferred bar size, let us pick 22 millimeter. So after selecting all this, let us now click on grid only. Our intention is to draw the total column to column, outer column to outer column distance which is 18 meter by 18 meter the building. To draw this portion first, and for that we will be drawing grid lines at 1 meter distance each. So to cover 18 meter in x and y direction both, we have to draw 19 grids. So let us make 19 x grid and 19 y grid, and the grid spacing as 1 meter as I told. So let us click on OK. Here is the grid for the building, for the foundation. Presently it is showing the building outline, building center along outer peripheral center only. Now let us start defining properties like material properties. Let us start by defining first the material properties. In the define menu, let us click material, then add new material. This material will be concrete, that will be N40. N40 concrete, and we have to select all the correct properties for concrete. We have to edit these default values to our desired values. Press OK after defining the concrete N40. Now add another material, the rebar, that is HYSP 500 material type rebar. Similarly, we are changing the value to a desired one. It will be 500. Then this is, so click on OK. After defining both the material, click on OK. Now let us define the footing slab properties. Click add new property. Let us give the name mat footing. Material will be N40. The type will be slab. Let us choose the thickness. For now, we are assuming a thickness 300 millimeter. Click on OK. So the slab property is defined. Click on OK. Now let us define the column properties. Now, as we have already seen that there are 16 columns, but only two types of columns are there. One is 500 square, another is 600 square. So let us define column 500 into 500 as the first property. It will be N40. Size 500 by 500. Click OK. Another will be click OK. So these are the two column properties that we have defined. Now let us go to soil subgrade property definition. From define menu, we are changing the defined soil 1. Now in the problem statement, bearing capacity is given as 300 kN per meter square and the allowable settlement is given as 1 centimeter. So calculate subgrade modulus dividing 300 kN per meter square by 1 centimeter, that is 10 to the power minus 2 meter. We will get 3 into 10 to the power 4 kilonewton per meter cube. Click on OK. Click on OK. Now let us check the load patterns, load cases and load combinations. The load patterns are okay. Load cases, take light. This is also okay. And in the load combination, we have to define two combinations. Combination 1, linear adding. This will be the ultimate. This is for the ultimate load. Same parameter will be ultimate. Another combination will be combination 2. This will be the service condition. This will be for dead load and this is for live load. This is for service design. Okay. Now click on OK. So both the combinations are defined. So with this, we have completed all the definitions. Now we will be starting drawing of the elements. So let us go to draw slab stroke area. First check that the type of object in the type of object box, the property mat footing is selected. So it's okay. Now let us start drawing this way, starting from the first node to and closing it on the first node again. Now let us select the slab like this. We can see that one area 4 points, 4 edges are selected. That means the slab is selected. As per our tutorial, the mat footing is projected by 2 meters on each side of the peripheral column gates. So after selecting the slab, we are now going to edit mode. Then edit areas, expand stroke sink areas, the offset value of 2 meter, that means 2000 millimeter. So now the 2 meter projection offset is drawn on all four sides of the slab. Now let us draw the columns. We have defined already the columns. So from draw menu, draw columns. Property above is 500 by 500. Property height above is 2 meter by 2 meter. So this column we will be drawing at all most of the locations. It is 12 locations except at C6, C7, C10 and C11. So let us start drawing. So these are the 500 by 500 columns. We have drawn them. Now let us take the 600 by 600 column. That will be for C6, C7, C10 and C11. So we have drawn all the 16 columns. Now we have to draw the design strips. So let us go to draw menu, then draw design strips. Use past the width of the strip that we have put here. The grid to grid distance of the building mat, foundation mat is 18 meter by 18 meter. So each of the dimension being 18, 0.25 of 18 is 4.5 meter. That would be the guideline. Let us consider design strip width as 4 meter. So let us, for strip layer A, let us put 4 meter. Now, while drawing the strips, right click on the outside, then again next strip. So all 4 design strips in strip layer A, the X direction is drawn. Similarly for strip layer B, we are drawing. So we have drawn the strips, design strip, faces strip. So all the elements are now drawn. Now let us start with assigning the soil properties and loads on individual columns. To assign the soil properties, first Let us select, clicking on the foundation mat. Let us select the foundation mat. One area 4 is selected. Now from assign menu and support data, soil properties, soil 1 has to be selected. Click OK. So soil property is assigned on the entire map. Now let us assign the column loads on the column points one by one, because all the column loads are different from one another. So we have to select each of the columns and assign the specified load over it. Let us first select C1. After selection, we have to check that the point is correctly selected. One point selected first. So C1 is selected. Now let us go to assign load data point loads. Here in the minor state direction, we have to put the column load under dead load. The first load is column load will be for C1. It is 18T, and the punching shear, that means the column size, is also required. Punching shear perimeter. So now let us click OK. Again, point load live load is 797.6 kilometer. Okay. Now let us select point C2, column C2. One point is selected. So assign load data point load. This will be dead load. For C2, dead load is 3013.3. Column dimension is again 500 by 500. We will be doing the 500 square column part so that we don't have to change the column size or punching shear size each time. So now the dead load. Select previous, assign load data. Now the live load, that is 1437. So this way, one by one, we have to assign all the column loads. So now we have completed assigning all the 16 point loads, both dead load and live load, and design strips. Right clicking on the footing after selecting it. In the design tab, we have to change the rebar material to HYSD 500. It's okay. It's okay. Now we have to do the same procedure for all the design strips. Let us do that. Now for the strip B, column strip B. So we have completed assigning all the HOST 500 rebar material to the footing and its design strips. Now the model is been saved and we shall do the analysis on the footing. Let us go to Run tab, Run menu, then click on Run Analysis. Analysis is being carried out. So after the analysis is over, what you can see that it's like a contour map. It is giving all the displacement values in the footing. Which we have to restrict within 1 centimeter. Now let us carry out the design for the footing. From the Run menu, click on Run Analysis and Design. So design is being carried out. Let us go to Display menu and Flow Punching Shear Design. So what we can see now that the punching shears are more than one in most of the columns. Even it is up to 4 at some columns, in the central columns like C6 to C7, C10, C11. So what we have to do now is that unlock the model and change the slab properties to instead of the thickness 500, we have to make it 1200. Click on OK. Again OK. Now let us run analysis and design again. So the analysis design is done. Let us we display again and check the punching shear. Now all the punching shear has come within 1. So that's it. The model is been designed properly. We can see the export view option from where we can see our footing that we have designed. The design of the model is okay now. So after the design part being over, let us check few things. The analysis, design and analysis and design results. Click on display. Now click on show strip forces. We can choose any load case or load combination and any type of load. So for dead load along layer A, we shall get all the diagrams. Similarly, for layer B as well, the slab design can also be checked. Click on impose minimum reinforcement along layer A. This is the slab reinforcement along layer A. Similarly, we can get reinforcement along layer B. Like this, we can check the crack widths of top and bottom face for different load cases and combinations. Now, to generate the rebar details, let us click on detailing. Let us click on run and click on run detailing. Check all the three options and click on OK. So the detailing is done. Now, if we expand the drawing components view, we can get the, after double clicking on each of the options, we can click the river table, river schedule, deal of quantities. To look at the different views, we can get top bar plan, bottom bar plan, even any of the sections we can see, and also the reinforcement profiles are being shown along X and Y, along strip layer A, along strip layer B. So we have successfully completed the design of the mat footing using SAFE software, and thereby we are concluding this.